Hi, hi. Today we shall be developing structural equation model which is called SEM, and here we have few unobserved variables such as number one variable is positive attitude, number two variable is research facilities and number three variables is research institutions. So these variables are called unobserved variables, meaning that these variables do not have any data, and these variables are also called latent variables. Okay, and here what I have done, actually my target is to develop a model on this topic. The topic is an innovator attitude towards innovation and success. So that is the topics of this model. So what I have done, I have asked 400 innovators about their attitude towards innovation and success, and I have made them following questions. An example, suppose A1, A2, A3 are the indicators of our unobserved variable such as positive attitude, right? Okay, here is the model. An innovator attitude towards innovation and success. So I have three latent variable. Number one, positive attitude. Number two, research facilities. And number three, research institution. And these three variables can be measured by some indicators, and the indicators are here. Suppose number one, this is the first indicators. I can gain huge from this new innovation. Number two indicator, I can change the world from this innovation. And number three, my partners will remain loyal. So actually I am making all these three questions to the 400 innovators. And the first indicator is A1, second indicator is A2, and the third indicator is A3. So this A1, A2 and A3 can measure positive attitude of the innovator. Okay, and second one, research facilities. Here number one question I made, enough equipments are needed for research, that is B1. Environment needs to be friendly for research, that is B2. And number three, conducive government policy, that is B3. So B1, B2, B3 actually can measure research facilities and so on. And the third one, research institutions, right? So this is the question number 1, that is C1, and that is the question number 2, C2, and this is question number 3 is C3, right? Okay, and I told to the innovator, you answer according to the following scale. Suppose strongly agree, then you just write 1. If you just agree, then write 2. If you somewhat agree, write 3. And if you disagree, then write 4. And if you strongly disagree, write 5. Suppose I make this question, number 1, should be independent in policy making. So maybe someone will choose 1, someone will choose 3, someone will choose 5. Okay. So in this way, all the data I have collected from 400 innovators, and actually these 1, 2, 3 are called Likert scale. Excuse me, Likert scale 1, 2, 3, 4, 5, and the data I can show you. The data I have collected already, they are here. You can see all the data, right? Say A1, A2, A3, B1, B2, B3, and then C1, C2, C3, right? These are the indicators, right? And you can see the data are from 1 to 1 to 5. Okay, here mistakenly 7 has come. Sorry, they have done a mistake. I think some people done mistake. So so the data should be 1 to 5. You can see the data from here should be 1 to 5, but maybe some people can put some wrong digits by mistake. It is possible. So however, data is here like this, 1 to 5, right? You can see 1 to 5, and you can see there are 400 innovators, right? And their answers, and also you can see from this side all the data. Yeah, it is all 1 to 5, but I told you maybe some person may put different number mistakenly. It is likely, so we cannot avoid the mistakes, but I think it is all right so far. Maybe some mistakes are there somewhere, right? Okay, so this is the data so far that you have seen from innovator 1 to innovator 400. Now we can run the model, structural equation model, and you can see structural equation model has two shape, that is estimate. One is unstandardized and the second one is standardized. So in the previous video I have already estimated unstandardized one, and now I shall estimate standardized one, right? Okay, how to estimate standardized one? Okay, so I go to statistics to estimate it. So I come here, right? And you can see the data here is just you click it, all data will come up. Okay, however, I go to statistics and I go to structural equation model, then I go to model building and estimation. Okay, so here I can develop our model figure, right? That I shall do now. Okay, what I do, I make it slightly big. You just click it, it will become slightly big. Suppose I make it 8 and this one I make it 5, something like that. Then I click, so it has become big, right, so far. Okay, then I set my variables, right, because I have 3 variables. The 3 variables are, one is positive attitude, and the second one research facilities, and the third one research institution. So from here I choose this icon. You can see from here I choose this icon and I set it here. Okay, so it is the latent variable, right, or unobserved variable. So the first variable is positive attitude. So I just write attitude because positive attitude is a big writing. So I just write attitude, and here is measurement variables. How to measure this attitude? I need some indicators. Actually we have already 3 indicators. One is A1, A2 and A3 that we have already seen. And then measurement direction, I take it left, right? I select left. Okay, so it is set, the model is set, right? Then I press OK. Okay, it has come up. You can see attitude, right? Attitude, and she has 3 indicators. Okay, then our second variable is research facility. Okay, that I estimate here. Okay, the second one is research facilities. I just write facilities, right, just in brief, and it has also 3 indicators. Of course you can take 3, 4, 5 indicators, it is up to you, but I have taken 3, and B1, B2, B3 are the indicators, and the direction I take it right, I take it right, so that whole model will be in the right portion. So everything is set. I click OK. Okay, so these two are done. Now the third one is research institution. So I take it here, somewhere here, research institutions. Okay, I just write institution, right? Institution. And she has also three indicators, C1, C2, C3. And I do it down, right? The direction is down. I choose it. Then I click OK. So the model is ready now, right? Okay. I can make it slightly big so that you can see better. Okay, I make it big. Okay. Okay, here you can see this is the square box. So this box is called observed variables. The variables we can see. That means data is there, right? This is observed variables. And also we can call these three boxes as dependent variable. Why? Because the cause is the arrow is coming to it. Arrow is coming to it, right? So we can call it dependent variable. And what about this one? Attitude. Attitude actually it is an independent variable because the arrow is going from it. So it is a independent variable, and this variable is also unobserved variable or latent variable. Same meaning. Unobserved variable, and also we can call it latent variable. And here is also same thing. We have three dependent variable, right? B1, B2, B3, and the facilities is the independent variable or latent variable. And these boxes are called error term, right? Error 1, error 2, error 3, error 5, 6, right? Right. So because in a regression model, we need the error term. So that is why this is the error term, and this one is also unobserved because it is round. Unobserved variables, right? Unobserved. Okay, what I can do now, I just make it slightly big, right? I can do that. If you want, you can do it. Just you can give some space, right? You can arrange slightly, right? Just make some space, right? Just 1 minute. Okay. Just giving a space, and I can give some space here, right? So some space are here. Okay, just we have given some space. We can do that, right? If you want, you can do it. Okay. Okay, I think it is, we have done it so far. Okay, okay, now we want to check whether there is a associationship between attitude, facilities and institution. That we want to check. So I select this one, add covariance, right? Here I select this one and I connect this to this one, and you can make it big slightly if you want. Then I can also connect this one, and I can also connect this one, right? And you can do some make up, right, and so on. Okay, you just go there, right, and deselect it. Okay. Okay, so the model is set. You can see model is set and the data is set. But this time we shall estimate standardized estimates, not unstandardized. And when we shall estimate standardized estimates, then this associationship is actually correlation, not covariance. I'm telling again, here the method is standardized, and when the method is standardized, then this associationship is actually correlation, not covariance. Okay. Okay, but when we estimate unstandardized, then this associationship would be covariance, not correlation. Okay, so we can estimate the model because everything is set. So what I do, I go to estimations, then estimate the model, you can see. Okay, and there are three methods. So the first method I choose. Okay, but here our target is to estimate standardized. So we have to select it. So I go to reporting and I have to select display standardized coefficient and values. Only then standardized coefficient and values will appear, right? So you have to select it all the time if you want to estimate standardized. But if you do not select, then the outcome would be unstandardized. Okay, so here I select already, then I press OK. So I think the result is coming up gradually. Yes, the result has come up. So you can see, suppose talk about 0.7, 0.61 and 0.7. Actually, we can call it coefficient of the regression, and also 0.76, 0.6, and so on. So these are called coefficient of the regression. And what about this one? 0.43 and 0.16 and 0.19 is called the correlation coefficient, right? Suppose the correlation between attitude and institution is 0.16 and it is positive. That means they are positive correlation. What about this one? 0.43. The correlation between attitude and facility is 0.43%. Sorry, it is 0.43 and it is positive. That means attitude and facilities, they move in the same direction. Okay? Okay, now we can see the result also from here. From result, you can see the result has come up also at the back. You can see here, that is, these are our variables. We also can call it endogenous variables or dependent variables, right? And we can call these three as exogenous variables or latent variable or independent variable. Okay, and it is the structural equation model, right? And here is the outcome. You can see all the outcome, and it is the standardized estimates, right? And here you can see it is the coefficient, it is the standard error, it is the Z statistics, and it is the p-value, probability value, and this one is the independent variable and this one is the dependent variable, right? Okay, how to get this 16.58? So normally coefficient divided by standard error, you can get the Z statistics, and this one is the corresponding probability, right? Okay, here this attitude, is it significant variable to explain A1? Okay, we can see the p-value. P-value is very small, less than 5%. So meaning that attitude is a significant variable to explain A1. What is A1? A1 is the indicator. So in the same way, attitude is also significant to explain A2 because probability value is 0. So here I can see all the things are 0, right? So normally when the probability is less than 5%, that particular independent variable becomes significant. So that is the guideline. And if the probability value is more than 5%, then that particular variable, that particular independent variable is not significant to explain the dependent variable. So that is the guideline all the time. So here you can see, suppose I talk about this one, institution. Is it significant to explain C3? Yes, because p-value is very small, less than 5%. Okay, but actually our target is here, the covariance between attitude and facilities. What is attitude? It is positive attitude. And facilities, what is facilities? Research facilities, right? Okay, and as I told you, when we estimate the standardized model, then this covariance actually is a correlation, not covariance. Okay, and this is the coefficient, correlation coefficient between attitude and facilities. Okay, now we set the null hypothesis. Null is there is no correlation, right, between any two variables, right? Between two variables, and alternative is there is correlation between two variables in the population. Okay, so first I check correlation between attitude and facilities. So I check the p-value. It is the p-value and it is very small, less than 5%, meaning that I can reject null hypothesis and can accept alternative hypothesis, meaning that attitude and facilities, they are correlated in the population, and it is positive correlation, right? Positive correlation, because the sign is positive. Okay, then I talk about the second one, attitude versus institution. So 0.15 is the correlation coefficient. The probability value is 1.8%, which is less than 5%. So meaning that we can reject null hypothesis and can accept alternative hypothesis, meaning that attitude and institutions, they are correlated. Then finally, facilities and institution, yes, they are also correlated in the population, right? So they are actually all correlated in the real world. That is called population. Real world means the real world that we see around us. Okay, and they are correlated there. Okay, finally we want to check the overall model fit. Model fit, whether the model is fit or not. Overall model fit, fitness of model, right? Of the whole system model, right? So this one is actually, we can call it system model. Okay, so there are many criteria. So here we shall check only few criteria. Okay, first I check this one, LR test model, probability and chi-square value, right? It is called likelihood ratio test. And here the guideline is the probability must be non-significant to be model fit. Okay, here I am telling all the guideline so that you can see better. I just show the guidelines. Why is the guidelines? Okay, the guideline is normally we say that, okay, I think it's not here. It is okay, it is not here. However, I can tell you. Okay, so this thing, the probability chi-square, I just write here model fit. So the for case of chi-square, it should be not significant, right? That is the guideline. If it is significant, then the model is not fitted. So here the probability value is significant because it is less than 5%. So model is not fitted according to this criteria. Okay, but we have some more criteria, such as we can check. Okay, I go to statistics. Sorry, I go to not statistics. I go to our model. Come up here. Okay, estimates goodness of fit, overall goodness of fit. I select this one. Okay, then goodness of fit statistics. You click here. There are so many criteria. I choose all of the above, right? I choose all of the above. That means all criteria I choose. Then I press OK. Okay, then I check out it has been estimated at the back, right? Okay, so here the first one, the here it is not it is significant. It is significant, meaning that model is not fitted. Okay, then we check some more criteria. Suppose I write RMSEA. This should be less than. This should be less than. This should be less than. Just 1 minute. I double check before telling it. This should be less than 0.05 to be model fit. And here I check RMSE is actually the value is very close, right? But it should be less than 0.05, but it is 0.055. So it is very close, very close. So we can say that our model is fitted model, right? Our system model that we have estimated is a fitted model. Okay, then another criteria is there that the value of CFI and TLI should be close to 1, right? And if it is close to 1, then we can say the model is fitted. Okay, I go down to check it, CFI and TLI. You can see from here. Okay, CFI how much? 0.965 and TLI is also 0.948, and they are very close to 1. So we can say that our model is fitted. Okay, so what is the decision? According to CFI, TLI and RMSE, model is fitted. But according to the chi-square, model is not fitted. Now it is up to you to decide, right, whether you will accept this model or not. But the three fit statistics, is telling that model is fitted properly, then we can say the model is fitted and we are happy about the model that we have just developed, right? So I think we are done, and thank you very much for being with me for a while. Good day. Okay, good luck. I just make some. Okay, these are the terms of uses of this website. I can see it.